Hello, I hope you and your families are well and healthy. My name is Ozelim and I'm a Brazilian master's student at the Faculty of Architecture and Urbanism of the University of Brasília, Brazil. I'm glad to present this paper, which was written together with the Professor Gabriela Tenorio, Professor Monica Godin, and Professor Valerio Medeiros. The paper is entitled Adaptation on the Walkability Index as a first step to study its correlation with the number of fatal pedestrian accidents on urban roads. Case study, Hélio Prates Avenue, Ceilândia, Federal District, Brazil. Well, measuring the impacts of urban form variables on the quality of pedestrian paths is essential for the implementation of sustainable and safe urban mobility projects. This paper seeks to make adaptations on the use of tools that assess and correlate remotely the walkability by means of index calculations, urban form, and pedestrian road safety. We illustrate the adaptations in a case study on Hélio Prates Avenue, located in the city of Ceilândia, Federal District, Brazil. At first, I will introduce a few of the concepts behind our approach. There is an intimate relationship between the urban form and the transformations that occur in the urban environment. These changes can impact urban mobility and affect the quality and safety of pedestrians and roads. Urban form can be understood as the set of elements that make up the city, such as buildings, facades, streets and sidewalks, urban furniture and urban equipment, road infrastructure, road system, etc. Therefore, our main research objectives are to study the calculation method of the Walkability Index developed by the Institute of Transport and Development Policies ITDP Brazil, to propose an adaptation and illustrate the application of the method on a urban road in the Federal District that shows large number of fatal pedestrian accidents, and to discuss the use of Google Tools, GeoPortal, with its local government website, and the GIS software ArcGIS for data specialization and representation of accidents, accident rate, and location on the map. We will now discuss the motivation behind our work. One of the main changes related to post-war cities is the accelerated growth and spread of urban space, as well as the change in means of transport, in which individual motor vehicles have gained even more priority in the construction of city spaces. As a result, the number of road accidents has also grown exponentially. This way, cities that should be for people ended up becoming cities for cars. In these photos, we can compare three scenarios and observe that cars always occupy more space compared to the use of public transport and bicycles. The image of the pyramids is a great example of what the order of priority should look like in the mobility system of cities. Since pedestrians are the most fragile individuals, they should always be at the top and cars at the bottom of the pyramids. When analyzing data on Brazilian modes of transport, it is observed that 28% of population walk and 45% use public transport. Considering that, in most cases, to reach the final destination, it's necessary to walk a few kilometers or meters on foot, then it can be considered that in reality, 73% of population walks at some point along the day. In Brazilian cities, the people who walk the most daily are the low-income people, and it's exactly in these regions where such population lives and works that infrastructure is worse. In this picture, we can see a woman walking on a sidewalk that has several obstacles, unevenness, and dangers. When we talk about road safety numbers, study shows that Brazil is in the 90th position of the highest number of traffic deaths in the American rank. The most vulnerable victims are motorcycles with 23%, pedestrians with 22%, and cyclists with 3%. Regarding fatal accidents that occur in the Federal District region of the capital of Brazil, it was observed that between January of 2010 to May of 2020, there were a total of 1,237 fatal accidents, and of those 542 were pedestrians being run over. Among the roads in the Federal District, Hélio Prates Avenue, located in the city of Ceilândia, was the one with the highest number of fatalities. So, our methodology will base it on the following step: theoretical framework on walkability and the Walkability Index, selection of metrics and adaptation of the Walkability Index method, characterization of the case study of Hélio Prates, calculation of the adapted iCam Walkability Index, specialization, the result with ArcGIS, and the conclusion. Some of the main benefits of walkable city is that they provide a more economical, healthy, happy, and safe lifestyle for people. They also bring new experience and better connection between people and space, stimulate creativity, bring equity, are accessible and have comfortable space for everyone, and have greater attraction and diversity of use. So, what is walkability? Thus, along with the ideas of walkable cities, the concept of walkability arises, which use methods to assess and measure how appropriate and safe a building environment is to walk. It can also assess how urban form influences path choice by relating aspects such as fluidity of travel on foot, quality of sidewalks and crossing, vegetation tree existence, public and road safety, size of the blocks, presence of road cycle infrastructure, etc. Walkability metrics can also be combined and mathematically evaluated by using walkability indices, which are numerical indices for assessing space and measuring the walkability of location. Typically, the methodologies include site survey, analysis by satellite images, questionnaires, and geographic information system. NAPSCOG and others indicate that the calculation of walkability indices on a local scale like neighborhoods provide a better assessment of potentialities and weaknesses of these methodologies. When the scale increases, there is a need for automation of data collection procedures. For this, the use of online maps and GIS software can be extremely useful. NAPSCOG and others also state that site survey is an important complement and cannot be totally discarded because some important data cannot be obtained remotely. Thus, this paper assesses how Google Tools, GeoPortal, and GIS software, in particular ArcGIS, can be used to collect, visually evaluate, and numerically calculate the first approximation of walkability index. So why enable a remote assessment? Site surveys are not feasible for assessing large areas. Remote assessment facilitates initial data collection, current situation of social distance imposed by COVID-19 pandemic, and use of GIS tools allows developing data in order to study possible correlations. For the present study, the method of assessment of the walkability index proposed by the Institute of Transport and Development Policies ITDP Brazil iCam was chosen, as it is based on several international and national studies such as Bradshaw, ITDP, Walkability Research, and WalkScore. So, the ITDP is a non-profit organization that was incorporated in Washington in 1985 and headquartered in New York City. Its mission is to promote environmentally sustainable and equitable transport around the world, and its audience is mostly composed by municipal governments. For the application of the methods, the basic unit of data collection and evaluation of metrics for the final calculation of the iCam is the sidewalk segments, like in this picture. According to the iCam method, it is necessary to individually evaluate the metrics of each category and give each one a score rating from 0 to 3. For example, 3 is excellent, 2 is good, 1 is sufficient, and 0 is insufficient. We can seek to synthesize the parameters that influence walkability and consider several aspects of the urban form. As indicated in the table, originally the method is divided into 6 categories and 16 metrics. Originally, data collection is based on primary data, like site survey, and secondary data, like pre-existing documentation, area or satellite photographs, and georeferencing resources. So, we intend to invert this data prioritization. Therefore, in order to perform adaptation on the method, we had to choose some metrics to discard and others to be included. The criterion of choice was based primarily on the ease and possibility of collecting the data through the online maps of Google Maps and GeoPortal. So the metrics day and night, pedestrian flow, noise pollution, and garbage collection and cleaning were removed, and the metric runover was added. After the changes above, the adapted method accounted for a total 13 metrics for the evaluation of the adapted iCam. Now, we will present our case study to demonstrate the application of the adapted method. Ceilândia is a city located 26 km far from Brasília, capital of Brazil. It was founded in 1971, and the Hélio Prates Avenue is one of the main commercial avenues in the city of Ceilândia. Hélio Prates has 3.5 km of length and is an arterial road. Some images obtained by Google Street View exemplify the current state of paths along Hélio Prates Avenue. In this picture, we can see some problems like the size of parking lots, lack of traffic sign and crosswalks. The direct coexistence with cars is also a worrying factor, as some of those park on the sidewalks and obstruct pedestrian space. This aspect causes insecurity for pedestrians, which can cause risk of accidents and falls. In addition, they induce pedestrians to walk along the roads rather than on the sidewalk themselves. Despite the stores are closed in these photos, we have an idea of the width and of the permeable and active facades. The trees are planted away from the main pedestrian flows, and the store marquee are not enough to protect pedestrians. In this photo, previous observation and problems are repeated. In addition to the lack of sidewalks, we can highlight the bus stop that is located inside the parking area and without separation or protection close to the road. Thus, pedestrians do not have a safety area to wait for public transport. In this other picture, we can see the bus stop is lost in space and there are no sidewalks, nearby buildings, traffic signs, and no other type of attraction for pedestrians. In this photo, we can see the degradation and discontinuity of the sidewalks. At the same time, a couple of pedestrians crossing the street in a place of high risk. The road as a whole has many segments with uneven pavements, holes, irregularities, lack of maintenance, blocking along the way, and in some portions there is no paving. Finally, in this image, we can see the difference in proportion of the size of the sidewalks and the parking areas. It is also noticed that there are no traffic signs and that the pedestrians are crossing the road in an appropriate place. Shading is also an issue, and it was observed that although there are lighting points, they are not for pedestrian paths. In fact, they are installed inside the parking lots, and this can cause strong security in relation to walking during the night. In this cross-section, we can see that most of the space are intended for cars and for the median street areas. The case study area Hélio Prates Avenue has a lot of sidewalks with the same characteristics and similar dimensions. Therefore, for the calculation of the iCam adapted, the avenue blocks were considered as the minimal study units. A total of 16 segments of a varying size were analyzed. Each segment was drawn using ArcGIS software, evaluating individually and scored according to the iCam criteria. For the evaluation for each segment, data from satellite images from the year 2018 and 2019 were used from GeoPortal, Google Earth, and Google Street View. These are the 16 segments divided along the entire avenue. These are the criteria defined by the ITDP Brazil for analyzing each of the metrics. Metrics with asterisks were disregarded in the remote assessment. So, after evaluating each segment, each one of those who scored according to the criteria ITDP Brazil, this way it was possible to have the value of each metric for each segment and at the end calculate the total score for the segments. The score of the final iCam adapted was 1.25 points. It's likely sufficient. No one of the metrics were considered excellent, and just 4 metrics were good, 3 metrics were sufficient, and 6 metrics were insufficient. ArcGIS software was used to specialize the calculated iCam data and georeference the location of fatal pedestrian accidents. The accidents locations were collected at the website of the Transportation Department of the Federal District from 2018 to 2017. Therefore, it was possible to obtain several maps that overlap the values of the metrics of each segment to the approximated locations of fatal pedestrian accidents. Next, some segments will be presented, illustrating the analysis and visualization of the results. A metric was considered for each variable group in order to summarize the software's functionality in the research. The area's overall score was 1.25 on a scale from 0 to 3. This indicates that the avenue has some potential but many problems. We can see that most accidents were in or near the insufficient segments. There is a visual clustering of the occurrence of accidents close to the red sections. Regarding the width, it is possible to notice that there does not seem to be pronounced relationship between accidents and this metric. Note that even in places with excellent width in green, accidents were observed. Hélio Prates Avenue offers excellent availability of public transportation. In relation to accidents, there seems to be a correlation, even if a little weak, between the such occurrence and the distance to get the public transport. Note that most accidents occurred in segments with greater distance, shown in yellow compared to green. Due to the fact that there are many commercial stores along the road, the score related to the facade was sufficient. However, it was not possible to correlate this metric directly with the number of accidents, as these occurred all over the road. More data and segments would be needed for a better understanding. The region has little, if any, diversity of use such as mixed use and public day and night use. Even though it is a shopping commercial road, most stores are only open until 7 p.m. In the case of accidents, as all sections were indicated as insufficient, it is not possible to establish a correlation. Therefore, more segments or other routes need to be analyzed. For this metric, it is noted that in many points of the avenue the crossings are not existent, inadequate, or barely visible. In the case of the accidents, as all sections were indicated as insufficient, thus it is not possible to establish a direct correlation. Therefore, more segments of other roads need to be analyzed. It should be noted that for the street-light metric, most accidents are close to places with color levels, like orange and red. This suggests that there is a correlation between the occurrence of accident and lighting. Regarding accidents, there is a clustering of occurrence of accidents near the place with bad indices, like red and orange, which suggest a correlation with shadow and shelter. Regarding the remote assessment, the main advantages are fast data collection, easy to see the main problems, easy to assess in large areas, and safety and comfort, while the main disadvantages are images are not of the current moment, can see details like holes and trash, and it's not possible to assess the flow of people and noise pollution. So, in general, the remote application made it possible to assess the area quickly and directly, proving to be a good option for a quick assessment. Although it was possible to remotely evaluate most of metrics, the need for a site survey was observed to properly account for metrics such as crossing and lighting, and besides a field visit would enable collecting data regarding pedestrian flow, noise pollution, garbage collection, and cleaning. We also observed that need to add metrics related to bike paths and cycle lanes in the mobility category. Besides, the Google tools were very useful. ArcGIS aided visualizing the values of each metric of iCam adapted and the locations of fatal pedestrian accidents. The GIS tool makes it practical to combine data, allowing us to identify the most sensible walkability metrics with respect to accidents. So, this article could be a basis for future studies and discussions on the application of the walkability indices remotely, and on the correlation of walkability with factors of urban form that may affect the quality and road safety of pedestrians. This is the bibliographic reference. Thank you for your attention and for the opportunity to share my work and the chance to learn from the other colleagues. Thanks and have a nice week.